Hello, my name is Sophia Cherry and I'm the project manager for the Aerospace Engineering Senior Design Team, ARGOS. ARGOS stands for Advanced Robotic Gimbal and Orbital Simulator, which is a 3 degree of freedom modular mock satellite and test stand meant to simulate satellite movement in space. This project perfectly embodies Florida Tech's motto, ad astra per scientiam, meaning to the stars through science, because as more satellites in space reach their end of life, a method for either reviving or repurposing these unresponsive satellites becomes more and more relevant. The first step to this is designing a method to recreate the various motions of satellites in space. ARGOS is that first step. By recreating the roll, pitch, and yaw of varying satellite tumbles, we can begin to develop a method to catch and repurpose those unresponsive satellites. I'm really proud of the work this team is doing, and we look forward to showcasing it soon. So this project actually comes from a professor-proposed project led by a student. So Tyler, our systems engineer, works very closely with Dr. White, and his lab is working on creating an algorithm to kind of identify different satellites in space. And our project is supposed to help train that algorithm and show the various movements of those satellites. And then with his algorithm, he'll be able to train it and kind of apply that to eventually satellite with maybe a robotic arm or something to try and catch those unresponsive satellites in space and help reduce space debris. Just because space debris is becoming more and more relevant, right? If you look at pictures of the globe, you can kind of see like how much space debris is orbiting the globe right now, and we're just trying to, clean that up and get a beautiful image of Earth. So the first step, obviously, is kind of assembling our project, right? So we had to decide, how tall will our system be? How big does our satellite need to be? How big do our solar panels need to be? And luckily, our solar panels don't have to be as big as real-world solar panels, just because in the lab, there's going to be different cameras, and with Dr. White's algorithm, he can kind of move the cameras and position them so that the satellite solar panels look bigger than they are, or maybe the satellite looks bigger than it is. So a lot of it is just going to be camera angles and playing with that. But our satellite needs to have that visual of realism. So our project is motivated. We looked at tons of pictures online and just how to design like a fake looking satellite that will be real. And it also needs to be modular, right? So that maybe the satellite in space that we're looking to catch further down the road has an ion thruster, or it has a satellite dish, or as solar panels, right? We need to be able to add those components, take them off, add different components. So a lot of our components are 3D printed, and then we did some slight modifications there. And yeah.
My name is Seth Bush. I'm an aerospace engineering student with a focus on the astronautics side. And I am the lead structures engineer on the ARGOS team project. So Florida Tech has a really great system where they set up junior designs so that we can start to kind of get a judgment of like what kind of projects that we're looking into. We get to choose our projects, and we do a bunch of research figuring out how we're going to accomplish the project that we signed up for and were assigned. Moving on to Senior Design 1, that first semester of senior year, we start to really get into the nitty-gritty details of trying to get all of our requirements met that we defined in the previous semester. So we have to create a design, we have to actually create the model of the design, whether that be in CAD or however that the student would decide to do that. And then moving on to Senior Design 2, you have to make it. You have to have something physical to show at Showcase at the end of the year. And currently that's where we're at in this step, is we're trying to finalize some last minute details of the ARGOS system. And we're really looking forward to showing it off in April.
So for any student interested in aerospace engineering, I just want to say that it is a very rewarding major. You won't regret it. It can be pretty daunting at first, right? Like the names of some of the classes are going to be things that you're like, what does that even mean? But then as you get further along in your major, you're like, oh, this makes sense. I can do this. And you make great connections, great friends. This school has given me so many awesome connections that have helped me land industry internships and jobs. And I'm forever grateful for those experiences. I've got friends that will continue lifetimes of friendships, and I'm just really excited for that.